All right. Hello, Dr. A. So I recorded this once through and then realized that the way that I explained things was just way too sloppy and that I could organize it much better. So I'm going to give it a second jab. So what I first wanted to kind of start off talking about were more the obvious exterior parts that are more, I'll go from the lateral parts to the more medial parts. And the first thing that I wanted to talk about was the ventricles, because those are actually an incredibly helpful way of finding different parts of the brain. So if we were to open our brain up, we pull out our brain stem. So you have your lateral ventricles, which are these. And then within the inside of the thalamus, like wrapped around the thalamus and hypothalamus and the pons and the substantia nigra, you have this little seahorse looking thing, which is the third ventricle. And then you have the cerebral aqueduct that leads down to the fourth ventricle. And so if we kind of go look at this, I have to screen share. Okay. So if we go to our 3D objects and we look at our ventricles, you can see the lateral ventricles, which are the kind of like the long-tailed things, and they go stick all the way back. And then you have the third ventricle in here, and the cerebral aqueduct, little cerebral aqueduct, all the way down to the fourth ventricle. So if I were to go to some slices, very quick, easy way to see some of them. So you have your lateral ventricles that are right here. They're dead center. Then you have the fourth ventricle down here, because you know that the fourth ventricle is basically like kind of on the same plane as the cerebellum. That's an important feature for finding it. So like if I were to go back here, you can see that the fourth ventricle is basically on the same plane as the cerebellum. So then we go back in here, and if I wanted to do the third ventricle, here's our third ventricle, and then the cerebral aqueduct would be kind of like right in between here. So not kind of foster. The cerebral aqueduct, I think would be, yeah. So basically lateral ventricles, then you have your third ventricle, cerebral aqueduct, which is this little tiny part, really skinny area that kind of runs through the center of the brain. And then if we were to go back and look at like a clear view of the cerebellum, then we know that our fourth ventricle is down there. Okay, so next what I wanted to talk about were just some distinguishing features of when looking at the like exterior of the brain itself, rather than going inside of it first. So if we were to look on the outside, I'm going to put this back together quickly. Okay, for the purposes of, okay, so main things I kind of wanted to talk about were the primary motor cortex, primary sensory cortex, primary auditory cortex, and then the orbital frontal region and the prefrontal cortex, or the frontal pole. So if we kind of go look here and we take a look at our brain lobes, you can see the frontal lobe, you can see the parietal lobe, the occipital lobe, the primary visual cortex as well, and the temporal lobe. And the way that you can kind of distinguish between the frontal and parietal lobes is the thing called the central sulcus. So this main little ditch, or the sulcus, that kind of differentiates between the parietal and the frontal lobes. So if we go back here and take a look at this, we can see that our central sulcus is right here, I believe. Yes. So on the anterior side of the central sulcus, you have your precentral gyrus, which is the primary motor cortex. And then behind it, or posterior to the central sulcus, you have your post-central gyrus, which is your somatosensory cortex, primary sensory cortex. And then you have your superior temporal gyrus, which is right here, which is your primary auditory cortex. And then you have the pole, which is your primary visual, and the occipital lobe is your primary visual cortex back here. And then in addition to that, we were saying we have the orbital gyri, and so yeah, I imagine the primary motor cortex and sensory cortex and visual cortex and auditory cortex. Those are pretty self-explanatory. The orbital frontal cortex, or the orbital gyri, is an important one because it's involved in decision making and decision making basically. And then your frontal pole, which is your prefrontal cortex, is even higher than that. It's basically looking at planning and projecting the future events based on current events. So it's a whole nother level above just decision making. It's like planning for the future. Okay, so now if we can clearly see from here, we can see our cerebellum. The cerebellum is important for things like balance and gait and our vestibular system and implicit motor memory. And then in addition to that, we actually can see pretty clearly here, but we might as well go in here. So if we're looking at this guy, we can see the pons and the medulla and the cerebellum. So the cerebellum kind of sticks out like this, and those are they stick out and are pretty easy to see. I don't really need too many huge trail markers to find those. But so if we were to go and take a look at our brainstem, you can see the pons right here and the medulla. And so the pons is important because it helps with neurotransmitter production. And the medulla is important for things like autonomic functions like breathing and your heartbeat and things like that you have no control over, autonomic processes. Okay, so, and this, cerebellum, balance, joint, gait. And then, okay, so if we were to go kind of back into the center of brain, if we're gonna kind of go from the inside out as opposed to the outside in. So if we had our ventricles on here, and then there's the main thing that I like to start with is the corpus callosum, just because it's a nice starting place and it's very easy to kind of see everything around it. So that's this little strip, and it's the primary commissure between the two hemispheres. So it relays the majority of the information, or a lot of information, back and forth between the hemispheres. So a good picture of that, I believe, was in, this one's fine. No, that's not actually the one that I was thinking of. There's the putamen one. So the corpus callosum is this part. So it kind of like wraps around on the top, or like superior to the lateral ventricles. So if we go back here and take a look at our cross sections, pretty much all of them you can very clearly see the corpus callosum. Okay, so going from the corpus callosum and the lateral ventricles, we have our like midbrain, or not midbrain, but our basal ganglia area. And the basal ganglia has a couple different important parts. It has the putamen, the globus pallidus, and the caudate nucleus. So if we go back to these parts, so essentially the way that you can find the caudate nucleus is it sort of it's like hugging on the inside, or on the lateral side of the lateral ventricles. So rather than being on the kind of the inside where the thalamus is, it's on the outside. And then and that kind of like wraps around. So where's the good picture of the caudate nucleus? This one, yeah. So it's this green part that kind of like wraps around the lateral ventricle. And then you have the putamen and globus pallidus. So the putamen, here you would have the caudate nucleus that would wrap around kind of like that. You have the putamen right here. And then you have the globus pallidus, which is kind of like, so yeah, you have your caudate, and then you have the putamen, and then the globus pallidus is kind of like more medial from the putamen towards the more towards the thalamus. So, but it's anterior as well. So if we're kind of looking at in more anterior, we can see our lateral ventricle here, and we can find our caudate because it's like hugging the ventricles, right? And then you have the putamen right here, and then you have globus pallidus right here. And so the putamen is, all those three parts were part of the basal ganglia. You have, for the putamen, it's learning and motor control and speech. The globus pallidus is more conscious and proprioceptive movement. And the caudate nucleus is planning and the execution of movement. So caudate, putamen, globus pallidus. And this is a nice picture also, just because we can also see the internal capsule, which I don't think has a really good picture on the 3D images. But the internal capsule would basically kind of be, it like runs sort of between the caudate and putamen, kind of separates them out. And that's right here. And so there's different parts of it, but it's basically a big bundle of fibers, myelinated fibers that are neurons that send a lot of, like, it's a very clear thoroughfare for information going between the lower parts of the brain and the cerebral cortex. And then you, in addition to that, from here, you can actually also see the insula, which I believe, yeah, insula is kind of on the out. So it's more lateral to the putamen. And the insula is involved in like gustatory and smell senses and happiness, pain, disgust, things like that. Okay, so now let's go, we're going to move over to the limbic system. And the limbic system, oh, where did we go? You kind of, before I took this apart, if I take this off, it's kind of this weird little triangular thing that goes in between the ventricles and sort of wraps around underneath the ventricles as well. So when looking at it from our little model, you can see it's sort of like, that's the fornix, and then the hippocampal formations, they like kind of, the hippocampus pieces come together and it like create the fornix. And then right at the very bottoms of the hippocampus area, you have the amygdalas. So let me see. And then also since we're talking about it too, let's see. So the amygdala, you have the amygdala right here. And if we were to look at the hippocampal formations, here's your hippocampal formations. And then here's your fornix. So they kind of like wrap around up and in between the, like underneath, kind of underneath the corpus callosum. But they wrap it, kind of, the hippocampus sort of comes together into the fornix, and it's a partial commissure. It sort of works as a commissure, but not really, also at the same time. So these ones are a little bit tricky to find, but also while we're here, we can look at the nucleus accumbens before I get too far out. So, okay, yeah, the nucleus accumbens, because we're going to be looking at the same sort of slides, I just figured it's easier to find it that way. So the nucleus accumbens is anterior, but also inferior slightly to the putamen and globus pallidus. So it's, again, a little bit anterior to it. So we're going to try and, it's kind of a pain to find those, but we can find them. Actually, for the, let's see. So here's our caudate, because we can see our lateral ventricles. And here's our putamen. And so the nucleus accumbens, that's our insulas. So and remember we were saying that it was inferior and kind of inferior to the putamen. So here's our putamen still. Our insula is going to be over here. This is our putamen again. Caudate. You can kind of see the caudate a little bit more clearly there. But the nucleus accumbens is more difficult to find because it's quite small, but it's very important. It's part of our, it's like one of the main components of our reward circuit. So dopaminergic reward circuit. Let's see if I can get a good snap of it. So here's our putamen. We're still going more and more and more inferior. Nucleus accumbens, there we are. So yeah, basically the last time that you can see the putamen, then you go a little bit more inferior and it's right underneath there. Like right underneath kind of, but a little bit more medial. Okay, but then we were also wanting to go, and so like I was saying, the nucleus accumbens is really important for the dopaminergic reward circuit. But we wanted to do the hippocampus, the amygdala, and the fornix. And so the fornix would be a good, it's pretty easy to find the fornix just because it runs right in between the two ventricles. So we can kind of start there. If we start there, then we'll be able to kind of work our way backwards. So it's very easy to see it. You've got your corpus callosum, you've got your caudate, and then the fornix is just this part right here. Okay. So if we imagine this picture and we were kind of going more posterior, you'd know that the hippocampal formations kind of wrap back around away from the fornix. So we're going to be if we're looking at the fornix here, then we're also we're going to be kind of looking at this part of the hippocampal formations. So the hippocampal formations would be right here on either side. Oops, it's the lateral ventricle. Yeah, that's the hippocampal formation. And like we were saying, then the amygdala is slightly superior to the hippocampal formations. So your amygdalas would be right there and right here. And the hippocampal, this side doesn't even have a really good obvious view of it. But yeah, hippocampal formation right here and amygdala. And it kind of, again, another important thing is that it's running alongside the lateral ventricle. It's very close to it. The little like tails of it. So if you looked at it like this, you can see that you have the tails from the lateral ventricles, and you have your hippocampus right there. Okay, and so the hippocampus and amygdala and fornix are part of the limbic system. Hippocampus is learning and memory, general learning and memory as far as we know. The amygdala is more involved in emotion and fear and emotional memory. A lot of trauma stuff is related to that. And then the fornix is more episodic memory recall. All right, and so the last couple things, there were a few more things I wanted to talk about: the thalamus, the hypothalamus, and then the cingulate gyruses and the substantia nigra. So let's go to, so the thalamus and hypothalamus essentially would be kind of in here. So if you imagine like taking away the ventricles, this mass right in the center here, that's your thalamus. And thalamus is the main relay station for all of your main senses. So all of your your like touch, hearing, visual, all of that actually goes through the thalamus. And the hypothalamus is immediately below it. And it's a little bit more of higher order. So if we're looking at the thalamus here, so here's the hypothalamus. It's basically kind of like right underneath where the ventricle heads would be. So that's kind of an easy way to figure out where that is. So if you're looking at like if we were to look from the top down or the horizontal, it'd be once you get underneath or inferior to the ventricles, you'll be able to start seeing the hypothalamus. And the thalamus is like hugging on the inside. It's just this big, the big mass kind of, it's more medial to the putamen, but it's the mass that's sort of in between all of the ventricles. So if we were to go back here, okay, so this is going to be our thalamus. And then if we were to also, so there's the subthalamus, and there's not a very good picture of the hypothalamus here. But if we go, we don't want to go so low that we start seeing the eye cavities. But it's right, so here's our third ventricle. Actually, you know what, let's see. So that's the thalamus, midbrain. But actually, I think we want to be a little bit more anterior. So if we go a little bit more, that's going to be substantia nigra down there. Thalamus, hypothalamus. There we go. Yeah, we needed to be a little bit more anterior. So the hypothalamus is, like I said, the thalamus is really important because it's like the main relay station for all of our senses. And then the hypothalamus is involved in fight, flight, fornication, and what was the fourth F? There was the fourth F, feeding and food. So involved in like hunger and eating and things like that. And then the last thing that I was wanting to show was the substantia nigra. And that's important for relaying motor information from the cortex and the cerebellum to the spinal cord. So if we look at this, that's actually not the most helpful one. But yeah, basically, it's very much like in the midbrain area. I don't know if it's actually midbrain or not, but I do know that we can easily find it this way. But basically, like, it's inferior to the hypothalamus. So like we were saying, the subthalamus and the thalamus is right here. Your substantia nigra is right in here. And it's kind of, yeah, it like wraps around the third ventricle. It's pretty much right around the third ventricle, just like the hypothalamus. And I think that basically does it. I talked about the lobes, and you know that the lobes, you have your main you have your temporal lobe, your occipital lobe, your parietal lobe, frontal lobe, central sulcus right here that defines the frontal lobe from the parietal lobe. And I think that basically does it. I don't think I missed too much. I hope that that was a clear enough explanation as to how I would go and find things. But this was definitely a very helpful exercise. So I appreciate you having us do this. It's pretty fun too. And I apologize for not playing any music, but I needed to focus a little bit more than that. All right. Thank you, Dr. A. See you tomorrow.